Okay, part E of the review is Kramer's rule. Number 11, I will expect you to do this by hand. Again, you can use a calculator to check your answer, but we will do this one by hand. So when you're using Kramer's rule to solve for x, this is when you do determinants of two matrices. The one on bottom is simply the coefficients of your x, y's, and in this case for number 12, z's. But that would be 1, 2, and then 2, negative 3. And if I'm solving for x on top, what I do is I take out the coefficients for x, which were 1 and 2, and I put the answers on the right side in the places of the x's. The y's will stay the same. And then down here for my y, my bottom matrix is still 1, 2, 2, negative 3. But in the numerator, since I'm solving for y, this time I'll replace the y column, 2, negative 3. I'm going to replace those with 11 and negative 6. The x coefficients will remain, so 1, 2. And then we will do determinants. That's downhill, 11 times negative 3, minus uphill, negative 6 times 2 would be negative 12, over 1 times negative 3, minus uphill, which is 2 times 2 is 4. And then we clean that up. Minus and negative 12 is addition, so negative 33 plus 12 is negative 21, over negative 3 minus 4 is negative 7. Negative 21 over 7 is 3, so there's our answer for x. And then for y, the good thing is I've already done the determinant of the bottom. I know that one's going to be negative 7 because I did that when I solved for x. Now I need to do downhill on top minus the uphill, so negative 6 minus 22. That gives you negative 28 over negative 7, which is 4. So there's my y on number 11. And then I like to write that as an ordered pair. I'm not going to be so picky that if you don't write it as an ordered pair, I would count off. I would accept if you want to say x equals 3 and y equals 4. I'm okay with that also. Number 12 is a little bit uglier. You are allowed to use a calculator for number 12, but I do want you to set up or show me what you do. So when I solve for x, on bottom I'll put the coefficients. In this case, there's an x, y, and z. So the coefficients of x, y, and z are 1, 2y. There are no z's for the first equation. For the second one, there are no x's, 3y's, negative 4z's. And then on the bottom, there is 1x, 6y, and 1z. And I'll do that determinant. And then in the numerator, if I'm solving for x, I take out my x coefficients and I put in the numbers on the right sides of the equation. So 12, 25, 20. And then the other two columns stay the same. So 2, 3, 6, 0, negative 4, 1. And then we will throw that in the calculator. For y, bottom matrix stays the same, so I am simply going to cheat and do screenshots of it. Beautiful. And then on top, when I'm solving for y, if I'm solving for y, I take out the y coefficients, which are 2, 3, 6, and I put in 12, 25, and 20. And then my x and y columns stay the same. 1, 0, 1, 0, negative 4, 1. And then for z, bottom matrix stays the same. So I'll stick that under there. And then in top, since I'm solving for z, now I take out the z coefficients and I put in 12, 25, and 20. First two columns will stay the same. And then once you set these up, once you write all this out, I expect you to do the determinants in your calculator. So what I would do, I stored this one in my matrix for A, I stored this numerator for B, and I stored this numerator for C, and then the bottom one I stored for D, and the denominator is the same in all three of them, so I only have to do that determinant once. But then in your calculator, to do the determinant, you go to your catalog and you find the DET command, and then you just put in whatever you called your matrix. So determinant of matrix A, that's how I'd punch that in the calculator. So let me do that real quick. And I get 18 for the determinant of matrix A. The determinant of matrix B is 57. And the determinant of matrix C is negative 76. And then the determinant of the denominator is 19. Ooh. I may have plugged something in wrong for x, because that's kind of ugly. I believe 19 goes into the other two. So let's see, 57 divided by 19, that's 3. So we get 3 for y. Negative 76 divided by 19 is 4. Whoops, negative 4. So I got nice, sexy answers for y and z. I'm going to double check my matrix, my determinant for the first one, because I may have made a mistake. This could be right, but I'm going to double check and look at my matrix. Let's see. Let me go down and look at that matrix. And 12, 25, 20, 2, 3, 6, 0. Yeah, here's my mistake. On my calculator, I accidentally messed up this one. I accidentally plugged in negative 1 instead of negative 4. So let me go back in and fix that. That's going to change our answer for x. All right, so when I fix that in my calculator, instead of 18, you get a determinant of 114. Quite a difference. Whoops, let's go back to my regular pen. So I get 114, and 114 divided by 19 is 6. So that's a little bit better. So my answer is x is 6, y is 3, and z is negative 4. I may, on the test, just to save you some time, instead of asking you to find all 3 variables, I may simply say solve for y using Cramer's rule. And if I do that, you only have to do this middle one where you solve for y. If it throws you off by me asking you only for one, then find all 3 of them. There's nothing wrong with finding more than is asked. But I may only ask for 1 just to save you a little bit of time. Because if you can solve for 1, you could probably solve for all 3. There, and that's it for this video.